Okay, so we have this session today about deep learning and machine learning and basically AI applications in MATLAB. And the main reason for this session is to kind of bridge the gap, because we've been talking earlier about domain experts instead of having AI experts, because it's easier to take someone from a domain expert and actually teach them AI instead of taking a machine learning expert and trying to actually to get them to understand the physical system. And most of the development, when you talk about AI application that has been deployed in the market, happened with programming languages like Python, with libraries like TensorFlow and Caffe, and so on and so forth. So MATLAB is basically the bread and butter of all engineers. And it's the only one, it's the software that you kind of have to know across the field. So we kind of noticed that, there is a need to kind of have that gap kind of close between AI applications and some engineering softwares. So to kind of start with an introduction, I'm not going to put it in presentation view, because I'll be switching between the presentation actually using MATLAB. So to basically start with a quick introduction of MATLAB, MATLAB is a high-performance language for computation. So you kind of see some of the applications for it, or some of the domains. You're talking about math and computation, algorithm development, physical modeling, controls development, analysis, data analytics, data science. يعني بالعربي مسبعين الكارات. They're kind of involved in so many industries. So just to kind of make you aware of the full extent of it, when you see cars on the road these days, no one programs by hand anymore. Especially when you try to kind of integrate with a physical simulation model. So all the cars that you see on the road these days, spacecraft, space shuttles, are actually being programmed using MATLAB. When you use something like Simulink, when you have a graphical interface programming method, and you can actually integrate that and make it easier to see, understand, and test within a simulation environment. So among designs across different applications and industries, MATLAB is one of the main tools that people use, and the language of MATLAB is heavily more spoken across those industries, and there is less of a focus on that here in this region. So the idea of this, that if we start developing, which actually MathWorks, the company behind MATLAB, offers, if we start developing things within MATLAB, it will offer us a more integrated solution. Because if you see, for example, this screenshot is taken from a full vehicle model, an electric vehicle model, and it's also integrated with a grid in terms of charging. So I can actually simulate my grid, where my electricity is coming from. I can simulate the vehicle and how it actually works with all of its subsystems. So if I develop an AI algorithm for this, I can easily integrate it with the rest of the system and do a more generalized approach into development, and actually also dig deep into the details of how am I going to do this. So there's a huge added benefit of trying to kind of integrate the two tools together. So what I'm going to do today is by no means going to a technical deep dive, because that takes years with MATLAB. I'm not going to focus on the technicalities of AI algorithms, because that also takes a long time. All what I'm going to try to do here is just a bit of an introduction about the topic and some of the capabilities of what you can actually do in MATLAB when it comes to AI. So to start with one thing, when you talk about existing networks that people have developed, one of the most common ones is called AlXNet. And AlXNet it became really famous because of one very important feature. It's not a deep layer. Sorry? I'm going to be switching to MATLAB, so that's why I'm not doing it. And you'll see that in a second, so apologies about that. So if you look at AlXNet, one of the main features of AlXNet is that it's not deep like GoogleNet. It doesn't have many layers as GoogleNet, but the way it was constructed, it has two parallel paths or more parallel paths, and only 8 layers deep, and that actually enables it to be applicable on GPUs. So that network is very fast compared to other networks. So What MathWorks have tried to do is not to be isolated from the market. So they put an interface in place that you can take an existing network that was developed by some people and actually use it instead of having to reinvent the wheel. Because if you look at this network, it has been trained using 15 million high-resolution images with 22,000 classes, 22,000 objects. So if you kind of try to retrain an algorithm, which is not really difficult in MATLAB, but the amount of data that you need is going to be very challenging, which we're going to see in a minute. So I will start with a very basic example right here. So just give me a second. So this is a very simple example of taking taking an image, a live stream from the computer webcam directly, and use it either GoogleNet or AlexNet, something you can import that has been trained by other people. You can start using it right away, and you can basically do the interface with any hardware, and you can start importing something real time. I haven't started MATLAB in a while, so it might be a bit easy. The first thing you need to do is just basically configure the input size to match what the network has been trained as an input size. It has to kind of be consistent. And then you can just do this and take a screenshot, and it's going to show a goofy image of me right now, which is right here. So that was a funny shot. And it tried to do specify what it sees in the image. Obviously, there are a lot of objects. So what you can do is that you can do a live stream of things, and it tries to classify using GoogleNet, which has been trained on millions of images, and you can immediately notice that. So if I try something here, it can actually see what objects I'm trying to display. So that's something that could be tried straight on. And then with convolutional neural networks, one of the main features is that it tried to classify the class of the object within the confidence level of it. So it doesn't, on the figure, it actually shows one classification, but in reality, this is what it should give you. In reality, this is what it should give you. It should give you a classification with a confidence, with a confidence scale for different classification models of the top predictions of what it thinks it sees. So if we do a continuous image recognition of this, and so if we do something like this, it start classifying things, and you can start, you put something in front of the picture, and it actually starts seeing, and it says to a certain degree of confidence, this is actually a water bottle, it sees. So technically what I just did here with a very basic code that is offered directly from MathWorks, I can actually start using a classification network that has been trained by a lot of people, and I can start embedding this within my application if I have a certain application that I want to try to embed this to. And this is actually comes with this code itself. All the codes that I'm showing today, by the way, are demos that are provided by MATLAB. So if you go to the help on the top and you open the help, you're going to start seeing all of these examples, which you can actually start reusing right away. So what I just did here is that I took an already used, trained, excellent network, and I start using it right away. The interesting bit that you can actually do, which we will come to soon, is called it's called transfer learning. Where I have a really good network. How can I use it further to tailor it toward my application? So if we go back to, which I will get to, but before that, I want to get into another example, which is if I actually want to design my network, how can I easily do this? So we'll talk about one example of training a classifier, a convolutional neural network, to start classifying vehicles. You can feed it any data you want. You can do a classifier to classify dogs, cats, whatever it is. And so if we go back to MATLAB, I lost the mouse. Yeah, there it is. So let me just clear this for a second. So one other great thing is when you start looking through the demos, it actually, like, they do heavily document all their demos, all their examples, and actually they even go to the extent of explaining the theoretical background behind all their demos. And I wanted to do it this way instead of having specific demos, because you guys can take that, go back home, download MATLAB, and start using these same examples right away as a starting point. So MATLAB come with a bit of data that comes with it. So again, with AI, data, that's always the headache that comes with it. And we will talk about something else. So this comes with a set of images. So if you open this, what's being stored in your workspace, and you start seeing here, you're gonna see a lot of files with what looks like 4 coordinates. And what you start seeing here is that you also have a detector. So we'll go through this a bit by bit. The data that you see here, it's called labeled data. So when you open it, let's say you start show something here, and you want to see a small sample set of the data that you have and start exploring, and you do this. What shows up is this. And this is one of the most important things, because the 4 coordinates that you see are actually the label inside it. So if you want to train a certain system, you have to have a labeled data. So I have to actually tell the classifier that this picture has a vehicle, and the vehicle is in this location. So the 4 numbers that you see are in XY coordinates and the width and height of that box. So, and the most annoying part about this, when you start working with image processing and computer vision applications, is actually labeling the data and take it from someone who spent 4 days in a row trying to do this. So it's basically a nightmare. And if you go online, there's a huge data set that's being offered by so many institutes and universities of already labeled data, so you can try to actually figure that out and take that and use it directly within your application. Something interesting to mention here is that labeling data when you have something to work with is a very frustrating activity to go through. So MATLAB have tried to do something to the best they can. So if you go within their apps, you're going to see so many apps that they have here. And one of them is called the ground truth labeler, which they had in the past, where you can import a series of images, or you can actually import a video and go to each picture or each frame and start labeling your data within that. The interesting thing that they did after that, which was released in 2017 version onward, is they started trying to automate the process. So they start using conventional image processing algorithms to say, okay, I have a video, 30 frames a second, and there's a car moving. So if there's a car moving, I have to label it within every frame. And that's basically a nightmare. So in the first frame, you can select the vehicle, and you select the objects of interest, and you can select an algorithm. And the algorithms kind of range. Right now, that option is not really available because I have to import a video to make that option available. But when you set an algorithm, you can say, I want to do an optical flow recognition or tracking to kind of say, look at without understanding what the object is, just look at these pixels and try to see the gradient from one picture to the other and see where those pixels move, and to actually try to calculate the gradient and follow that object as it moves, so you don't have to label that object within every single frame. Another technique that they used is to use a pre-trained classifier to label your data. Obviously, you have to check that because it doesn't give you something 100% accurate. But that's why they call it partial automation. So you can actually say, I already have a classifier that recognizes vehicles. So I want to use that to label new data and use it to train further my algorithm. So that's one of the interesting things that kind of made the process a lot easier. And you can find a data set like those images, and you can start playing around and actually experience the full, let's say, how it actually works. So let's actually talk about constructing the convolutional neural network. If you want to construct a convolutional neural network, the first thing you have to consider is the data that you have. And you want to split that into training and validation. So because if I use a data that's already been trained to validate, then my design is already biased because it knows the answer already. So I have to take a small subset of the data and hide it from the network and reintroduce it later to see how well it does. And this is what you do. There are so many techniques into substituting splitting the data. So right now it kind of takes 60% of the data for training, and it hides the 40% later on for validation. And here you start creating the neural network. So you start actually by creating a layer by layer. So this is the input layer that basically takes the image within a certain size and start processing it. And then you do the filters and the convolution layers that you actually will create later on to kind of start doing the convolution process on the network. And then you have to put the final connected layer, which is basically the regression layer that says, oh, I analyzed those features from a convolution, and those features are the features of a vehicle. Those are the features of a car. So, and then you can just basically patch the whole thing together. You start from an input layer, middle layer, the convolutions, and the final regression layers, and then you can easily see within a few lines of code, you've actually designed a network, and you can see all the configurations or all the different layers. If you go to the presentation, that's what basically those layers actually mean. You have a convolution layer, a pooling layer, a ReLU layer, and then you have the regression layers at the end. So that's basically the design of the layer itself. And then what you can basically do is to configure training options to say how many times I want to iterate through the data and what is my initial learning rate. There are certain parameters that you have to understand and tweak to tune, basically, and to adjust your design. And here comes the training of the network. So I have this option of set to false because this data set comes with a pre-trained classifier. If I set this option to true, it will actually start training, but it will take a long time to actually go through the training, and you will see. Sorry. So here you can actually see the progress of how the training of the classifier starts happening, and it will start basically iterating through through all the data that you have multiple times, which is something called epoch. So what it starts doing is start taking the data and takes a single image and it divides that into small patches, and it starts cycling through all these images multiple times and through all these small patches to learn the features of what a car looks like. And it will tell you how many iterations versus how many cycles it goes through the patches. And it will show you the losses, and it will show you basically the accuracy of what it reaches to. So you can see that through the first iteration, it kind of reached within three cycles. It kind of reached a high accuracy. I'm going to stop the training, and I want to go back to the code because that takes a while. So the previously trained classifier, now you give it a validation data that you need to test, and you feed it a picture, and it should return something that looks like this. So this is a new image that the classifier hasn't seen before, and it says, I think there are two vehicles, and these are my confidence in that. So it gives a 99% to the first object. It's very clear, it's close. The second object, you can notice in the picture there is a bit of a glare, and it kind of takes a side view. So it has a bit of a less confidence in detecting that, which actually brings you to think about certain parameters. How many variation for your application do you have to kind of consider for the data set that you have? So if I want to train a classifier to detect pedestrian and deploy that on a vehicle, and I just take the front view, and all that data that I have look like this, and then someone comes along standing like this, and it might not actually recognize the pedestrian, and then you end up in a big trouble. So the variation that you want to induce in the data, it kind of heavily depend on the application. That's something that the person has to really think about in details before starting going through the technical cycle, basically. Because you can reach a point where you think, this doesn't actually work for my application, I have to restart the whole thing. We're doing good on time. So that's basically, we just quickly went through the design of a classifier, and here it can show you something. You can actually calculate certain metrics about how well your network is doing in terms of accuracy and precision, and how many times it actually classified something correctly. Because the 40% of the data that you put aside, you already know the true answer. You already know that the data is labeled. That 40% data is labeled. You know where the cars are. So when the network comes and classifies those images again, you know what's called the ground truth. So you can compare it to that and calculate certain metrics about how your network is doing. Any questions so far? Okay, no, since we're going through technical details, I just wanted to make, since we're going through technical information, feel free if you want to jump in with a question. If anything is not clear, I know it's a lot to absorb. It's a lot of information trying to condense in a short amount of time. So, let's talk about transfer learning, which is a very great thing since it has been invented. Because I can design a great network without having to go through the trouble of calculating lots of data. For example, AlexNet and GoogleNet have done a great job for me. You're training their classifiers on millions and millions of images and thousands of classes, okay? And those networks became really, really good at extracting features. So before you classify, first of all, you want to do the convolutions to extract features, and then you want to classify. So those are very complex networks. They became really good at extracting features. So how can I actually use that to my benefit? Instead of having a lot of data to train a classifier from scratch, I can actually grab something like this. What I can do is take the network, modify the network, and basically take the majority of the network. Because if you look at it, probably the previous picture might be more descriptive. So, because let's say the first few layers are the layers that do the convolution and try to extract the features out of a picture, and then the final layers are actually the layers that tell you what the object is. So what I can basically do is take a pre-existing network, keep all the layers, and basically get rid of the last layer, and then replace it with something I want to tailor to my application. Therefore, the network is already good at extracting features, and I can already just tailor the last layer to do something I want. So, okay. So let's say I take, I basically take AlexNet, and then I take a series of images, which I will show in a second. This is an example by MathWorks. So they have these sample of objects. MathWorks do a lot of promotions when they go places, so they have their own custom design, like a Rubik's Cube, or a flashlight, or a screwdriver, or a deck of cards, or a cap, or t-shirts. So that's just a sample picture of some of the things that, let's say I want to import new data to classify. And then I basically take AlexNet. If you look at the net and you start looking at the layers, you will see something. This is AlexNet. This is how it's basically designed. So I can see all the layers, and I can start actually dissecting the network. And then I can create a new object, take all the layers, except the last three ones. And here, basically, I reintroduce or recreate the last layer based on the number of objects that I want to classify now for my application. So the number of classes here are 5 for the data that I want to train on. And then you can start training the network. So therefore, I don't have to actually have a lot of data to go through. So here you can actually see the training process of the network, and you can actually see live how the network is doing with the new data set that you gave it. And it actually converged. It reached a high level of accuracy, and it minimized the loss quite quickly, because the original network that I adapted was really good at extracting features and understanding features within a picture. So therefore, it was, let's say, a lot more feasible to train it with less data. So, I should train this. So, give me a second. Looks like it's busy. Oh. So now I can give it a sample of the data and say, try to classify those images with the newly trained network, because the old network didn't know these objects. So now it actually classifies all of the objects to a very good degree of accuracy with the data. So, and you can see that the accuracy with a very small set of data reached 100% quite easily. Normally, if you want to reach a very high level of accuracy with data that you have to have maybe thousands or millions of images to kind of reach a very good level of accuracy. Because if you want to see how certain networks are basically designed, if you kind of look at, I will just show you one, like a structure of Google Net. The structure of Google Net, it's so complex, it looks like this. So imagine have to deal with so many layers and a very complex structure of a network to get to that extent. That basically takes years of work. So you can easily take that, and you can actually classify and retrain a network, and you can actually embed that in your application right away. One of the things I want to talk about is, I forgot to talk about this. One of the things I want to touch base on is basically few applications or few things that are embedded in MATLAB, which is you have something called MATLAB coder, and you have something called the GPU coder. So let's say I design something and I want to deploy it on a robot, okay? I can easily grab my application, which already support code generation, and I can click that, and I can just easily generate a C code. It will automatically generate a C code for me out of the model that I have, and it can go on whatever application, a car, a drone, a robot, whatever it is. And you have the GPU coder, which you can actually generate a code that works on NVIDIA processors. So it employs the parallel computing to kind of make the application a lot faster than it usually is. The last couple of things I want to touch base on are a bit far from the convolutional neural networks or the image applications. In MATLAB, you have one app called Classification Learner. They have all the algorithms for it, but they've designed an app interface to kind of make things a lot easier. So if we basically take this command, this is the only thing I need to run. I want to clear everything. So I can basically read this data, and this, if you look at it, it's called the Fisher table. Based on the name of a scientist. So this is for types of roses. So he's a biologist, and he started looking at different types of roses which I'm not really very familiar with the names. I'm not expert on that. But he started looking at certain parameters like the pedal length, the pedal width, and the pedals length and width, and start classifying based on the type. He just basically took measurements and recorded them and said, these are the measurements for different types of roses. So if I go basically, so if I come here and I already have the something called the classification learner, and if you talk about classification problems, normally you have lots of different types of algorithms, which kind of becomes a nightmare to deal with and try to kind of explore. So this is a very simple interface. You have the data in the workspace. You come here and say, I want the Fisher table, and it can already tell you what are the predictors and what is the response. So the predictors are the measurements of the pedal and settle, and the species is the thing that I want to try to classify. You can here tell how much of your data you want to use for training and how much you want to use for validation. So if you basically import that here, you can start actually exploring graphically your data to look at. So you can start by saying you have something called you have the scatter plot. So you can start to kind of plot the data and try to see the correlation between different things. And one easy thing you can do is that if you click here, you can see all the classification algorithms in one place. What you can simply do is say train all of them and tell me which one is the best one for me. So you have the decision tree classification algorithms, you have the quadratic discriminant, and then you can see, for example, support vector machines, and then you see Gaussian models, and you can see clustering algorithms as well. But for the sake of that, I want to start with training one classifier. I don't want to train all of them to start with. And I trained a classifier, and it already gives me a 95% accuracy. So if I come here and look at something called confusion matrix. So if I look at the confusion matrix, it will start telling me how good my trained model is at predicting things. So what this means is that the diagonal line, if you see, corresponds with a different, so the Setosa on the upper side, and it's on the x-axis as the first one. So that's 50 out of 50 accurate predictions. If you look at the bottom here, the Virginica, there is 3 missed classifications that classifies them as the versicolor, rose type. So you can see the misclassifications that happen here in the confusion matrix. You can quickly tell how your model is doing. And you can try to kind of adjust your training or look for something else. So if I look for, let's say, if I try to compare that with a Gaussian support vector machine algorithm to see how well it does compared to that, it actually gives me a better high accuracy than the decision tree matrix. And I can explore the difference between those easily. And you can, once you decide which algorithm give you the best result without overfitting your data, you can easily just export your model and you start integrating that within your application, whatever your application could be. You can even generate a code and deploy it on a website or on a mobile app, by the way. So that's the classification learner for classification problems. Not necessarily you can work with pure data, not necessarily images. So I kind of wanted to consider just to go through this example. Okay, so another example I want to go through is the regression learner. So now we talk about classification. You want to tell simply so this is a discrete problem. You want to tell if it's this type of rose or this type of like another flower or rose. When you talk about regression problems, you're talking about you're trying to kind of do a more a continuous estimation of a certain parameter. So let's look at this, and I will show you what that data is in a second. I think we have a few automotive people here in the room that might actually object to this. So if you look at this data, basically this is a data that was taken in the States. So it basically looks at different parameters for different vehicles. So it kind of considers how many cylinders it has, engine displacement, the volume of the engine, the horsepower, the model year, the weight of the vehicle, the origin, and the MPG, because this is actually what this model is trying to predict. So it's trying to take historical data from different vehicles and trying to predict the fuel economy of that vehicle. And you see variation here between American, German, or Japanese. I think the Japanese are better. I'll leave that as a statement out there. So let's take this data into consideration and actually see what we can do with it. So you come here and you have the regression learner. So let's see if I can actually build a decent model that I can feed it and say, okay, I want to feed it new data. I want to tell it, this is the make of the car, this is the model year, this is how many cylinders are in the engine, this is the capacity and the horsepower, and see if it actually can give me a decent estimate of the fuel economy to know how much fuel am I going to spend on that vehicle. So again, just simply go through and import the data from Workspace. We have a table that is made already. So it recognizes automatically that this is the response. This is the thing I want to predict. And I can, again, divide my data into cross-validation. And you can even say, I want to take it as a percentage instead of fold, so it doesn't shuffle the data. So let's keep 25% of the data hidden from the model to use it for validation and see how well it does. So again, we start seeing things. So let's see, does this data actually make sense? Okay, so let's try to plot things. So this is MPG, mile per gallon. And let's see what we have on the x-axis here so I can change certain things. So let's take, for example, horsepower. Does this data actually make sense? So this data suggests that when my horsepower increases, my fuel economy decreases. Okay, so you can actually see some sort of a really nice a quadratic curve between the two variables. You can start looking at the weight of the vehicle, how the weight of the vehicle actually impacts the fuel economy, and you will actually see more of a similar correlation here. This is an easy set of data to look at because the moment you look at the plot, you can actually start making sense of it. You don't have to do a lot of analysis to understand it. That the heavier the vehicle is, the more fuel it consumes. And then you can see some variations in terms of origin and how it actually impacts, because that's not really a quantifiable metric. It kind of changes. There are so many factors that it depends on. If you look at the model year, that's also not something that is very clear to compare. Over the years, you can see that there's a bit of a trend of fuel economy improving over the years, but you can see also a high variation within the same year. So enough with the analysis. Let's take something and start predicting or start looking at the model. So I want to take all linear models and say train all of them and see what you get. And it quickly loops all the data, and it gives you the something called RMSE, which is the root mean square error, which is kind of an indication of how well the model does. So the lower the value is, that means the less the error in your model, or the mean square, the root mean square error. So the better your model is at predicting things, and you can see. This is what my model looks like. This is what it predicts. And you can see here on this plot, the prediction, the true responses versus the predictive responses kind of go on a triangular line. So my scatter, if it's further away from the plot, the higher the error can be. So if you look at, let's say, something with a high value, you can see that the data is all skewed into one direction. So there is not really an even distribution to kind of tell me how well my model is doing. And if you also can look at something called residual plot to see the variation between what I'm actually truly predicting and what is the average of the residual in terms of a plus minus value, to actually take that into consideration when you try to use this model into your application, to kind of keep that in mind. And you can start comparing different algorithms. So let's say you want to use an exponential, a Gaussian process model, and you want to train, you can easily actually train tens of algorithms at the same time and try to compare those and see how well you do. So here we see an algorithm that does slightly better, and it has a better distribution of the data compared to the other algorithm. So that kind of gives me a better estimate. So I can easily export the model here into my workspace, and it tells me this is my model, trained model. If I go into cancel, so if I go into my workspace, it actually tells me here that it trained that this is the model. So here there are certain it actually exports a structure. So inside the structure, if you look at it, it tells you what the required variable. If you want to make a new prediction, you have to input all of these variables, and it will give you another response. If you go back to that structure, there is this regression object. It's a system object, so that is what you would use to predict, and it gives you something really nice which it says how to predict. So if I go here and say, so if I say train model and say how to predict, it basically tells me this is how I actually can do this. It tells me this is how I can call the function itself to say, call the function .predict function and enter a table of all of these values, of all of these input variables. And I can basically deploy this within a vehicle simulator, or I can deploy it on let's say, a traffic management system that can try to kind of estimate the fuel consumption of certain vehicles. The more data I have, the more accurate my prediction can be. So this can easily make it easier to integrate within your applications. So I've talked a lot. I want to take it easy for a bit. I know, and I apologize, there's a lot of information that I needed to cover. So we have 15 minutes left. We'll leave that for questions. Yeah, can we? There's no one. Yeah, if we can get the mic, please.
يعطيك العافية. You need it بصراحة.
كيف؟
You need it يعطيك العافية.
الله يعافيك يا رب.
ابتهال يونس.
أهلا وسهلا.
سؤالي للماتلاب. هلا الماتلاب لما بدي استخدمه في مرحلة إنه أنا رتبت الداتا عندي بتيبلز جاهزة، آخذها بهاي المرحلة وأدخلها على الماتلاب وأبلش أعمل أناليسيز، ولا بقدر أستعمل الماتلاب عشان آخذ رو داتا وانا اعمل اكستراكت الانفورميشن اللي انا بدي اياها زي ما انا بعمل بالبروجرامينج لانجويج تبعون الار والبيثون. فبدي اعرف بالضبط الماتلاب باي مرحله ممكن استعمله.
انا بالبدايه شو حكيت انه ماث وركس مسبعين الكارات، بحبوا يشتغلوا بكل شيء، نحكيها بالعربي. فبال اكشلي اذا انا اجيت هون على الابس اللي موجوده بالماتلاب واحد او الهوم بيج، حتى واحده من الابس اللي راح تلاقيها موجوده اللي هي امبورت داتا. فانا شو بقدر، يعني في ناس مثلا بيعملوا ابلكيشنز انهم يعملوا انترفيس للماتلاب مع ايمج اكوزيشن ديفايسز. مثلا انا بقدر اشبك تمبرتشر سنسورز دايركتلي سيريال كوميونيكيشن على الماتلاب واسحب الداتا انا كلها. بقدر اخذها من اكسل شيت، بقدر اخذها من اي كايند اوف فورمات، وانا ببلش افوت على الماتلاب. part of the process في كثير functions حتى انه انت تبلشي you can start cleaning and filtering and processing the data to make it ready. فانه بالعكس يعني you can actually start from the first stage، انه تجيب الرو داتا وتدخليها على الماتلاب and you can actually start pre-processing وتبلشي تجهزي الداتا اللي عندك before you can actually start designing the application. في اسئله ثانيه؟ في اسئله هون.
مرحبا.
اهلا.
يعطيك العافيه.
الله يعافيك.
ممكن تقترح علينا اي مكان على الانترنت او اي سورس على الانترنت الاقي فيه داتا جاهزه من اجل التدريب؟
ما هو انا ليش جبت انا هسه في كثير سورسز، depends. يعني انت بدك تحكي داتا، بدي اسالك شو داتا، images what are you trying to classify في 600 ألف مليون يعني data sources مليانين. بس أنا ليش جبت examples من الماتلاب؟ لأنه الماتلاب الماثوركس حاطين samples of data جاهزة مع الابلكيشنز والديموز. يعني أنت لما تنزل الماتلاب الانستليشن سايز تبعه على الجهاز عندك راح يكون تقريبا 6-7 جيجا، لأنه فعليا مليان resources internally موجودة راح تكون عندك offline. حتى you don't even have to go online to see things. You can easily go to the offline help. You can put what you want. So let's say I want to search regression. راح يفتح لي الهيلب سنتر، وأنا هون بقدر أقول له what am I actually looking for? Am I looking for a function? فإذا أنا فتحت على function راح يفرجيني regression function how it is, theoretically what it stands for. إذا أنا جيت هون وقلت له عمي أعطيني بس بدي ما بدي functions، أعطيني examples، راح يبلش يفرجيني examples، وكل واحد بيجي معه sample of data والكود جاهز to actually start running it. ففي samples أنت راح تلاقيها موجودة. That could be a good place to start حتى أنت تبلش تفهم الالجوريثمز كيف بتشتغل أو الenvironment كيف how you can deal with it. ففي سؤال تفضل.
الله يعطيك العافية.
الله يعافيك.
My question على learning transferring. When you did the learning transferring, you had to retrain the model once again on a new data set so it can identify the new objects that are not cars or
مظبوط.
vehicles. So my question exactly, where are the main benefits of transferring learning? Is it just to ease the programmer from reprogramming the model again, or is it also machine friendly so it can reduce the time and the process power taken for retraining the model? And one other quick question, is MATLAB resource friendly? Like, can it handle resource allocation so that I can reroute all the processing power to the GPU, since the GPU has the biggest capacity, much better than the CPU?
Yes, it has parallel processing. So that's the second question because it's the easier one. It has parallel processing where you can use multiple threads of the CPU at the same time. It has GPU enabled processing. فأنا لما بتقدر مثلا بدك تعمل training convolutional neural network، عندك large image set فيها 1000 صورة. إذا بدك تستنى على السي بي يو، مرة عملتها قبل 3 سنين، تركت اللابتوب على المجلة أسبوعين وهو عم يعمل تريننج، حاطه بالمطبخ مشان كل ما افوت اشوفه وما لحق يخلص. هسه في تولز موجوده اوريدي بالماتلاب، بتقدر انت تنزل لايبريز اسمها كودا من انفيديا. اذا عندك انفيديا جرافيكس كارد على الجهاز تبعك you can actually access the graphics card وتستخدمها كبارل بروسيسور. وفي عندهم هاي more of a business solutions لانه غاليه بيعملوها للبزنسز. في عندهم سيرفرز تقدر انت تعمل بوش للداتا تبعتك والداتا تروح على السيرفر، وفي عندهم ستاك اوف جي بي يوز ببلشوا هم يطحنوا لك بالداتا تبعتك ويرجعوا لك اياها. On the first question على قصة الترانسفير ليرنينج، حتى بس ارجع احكي بالموضوع هون بالترانسفير ليرنينج. لو حكينا مثلا عن أليكس نت، انا بدي ارجع اعملها ترانسفير ليرنينج. اول انا بديش ابعد عن المايك المشكله ولا بدي اقرب. فانت لما تبلش تشوف اللايرز من البدايه من الشمال لليمين، هذول كلهم بسموهم convolution layers. هذول مهمتهم to actually extract the features و learn the features. انه مثلا السياره انا راح اشوف curves ورا على البريك لايتس، راح اشوف مثلا الانر سايد تبع الرير ويندو، مثلا راح اشوف طرف العجال من ورا، راح اشوف اكزوست بايب. فبتبلش تفهم الفيتشرز تبعت السياره how it actually looks like. بعدين الفيتشرز هذول بالاخر انت بتدخل ايمج ماتريكس. الفيتشرز هذول بيطلعوا بسنجل فيكتور مش ماتريكس، بفوتوا على اللاست لايرز. اللاست لاير بتطلع على الفيكتور هذا، بتشوف فيه مجموعه من الفيتشرز، بتقول لك الفيتشرز هاي سياره. لما انا اخذ أليكس نت او جوجل نت، وهي هذول النتوركس they can predict 1000 classes. اوكي، الحلو فيهم لانه تدربوا على كثير داتا، الكونفولوشن لايرز اللي جواتهم tuned انه to extract as many features that actually make sense as possible. الكونفولوشن process. فانا بخلي كل هذول اللي هم this is the interesting part that I want اللي هو feature extraction is a very complex process. بس بشير آخر لاير بقول له يا عمي أنت you can predict 1000 class، أنا بديش إياهم، انا بس بدي تعطيني الفيتشرز، طلع لي الفيتشرز. بس يطلع لي الفيتشرز انا بقول له بدي اياهم بس لواحد اثنين ثلاثه، سياره ودراج وبدستريان مثلا، شخص بيمشي بالشارع، ل3 كلاسز بدل 1000. انت التريننج ما راح تعمله على الفول نتورك، انت التريننج بتعمله على الفاينل لاير بس. ف يعني you take what the network can do best, which is extracting features. عرفت؟ فانت بتكسب هاي الشغله. Any other questions? كيف؟ شو هي الفيتشر سelection؟ قصدك الكونفولوشن بروسيس؟ الكونفولوشن بروسيس من البدايه للنهايه بسموها فيتشر اكستراكشن. اوكي؟ فهون عندك الفولي كونكتد لاير بالاخر هي اللي بتاخذ الفيتشرز وبتحاول تفهم شو هو هذا الاوبجكت بناء على اللي انت دربته عليها. تفضل.
My question is about the same Alex network or the Google network, the convolution part of it. What are the weights that are used? Do you use weights like a normal neural network, or do you use some two-dimensional filters that do correlation between the images and the data and then get the features?
هسا it has weights and it has convolutions. It has weights and it has two-dimensional matrices. بالزمانات اول ما طلعت قصه الكونفولوشنز قبل قصص المشين ليرنينج، قصص الكونفولوشنز كثير قديمه بالايمج بروسيسنج قبل قصص الاي اي كلها.
We used Gabor filters, we used the different
exactly.
types of
فانت
filters.
مثلا في عندك السوبر فلترز اللي هو بيطلع لك مثلا الايدجز بالصوره، في عندك ايدج ديتكتورز، في عندك جاوسيان فلترز. هسه هون الفكره بالموضوع انه لما بلشوا بالكلاسيفيكيشن بلش يقول لك يا عمي طلع لي الايدجز، طلع لي الايدجز تبعت السياره وانا بحاول افهمهم لانه those are features I can understand. اوكي؟ لما شافوا انه الموضوع معقد وصلنا لمرحله ما قدرنا نطلع بالاكيورسي اكثر من هيك، هون فعليا اللي بصير جوا النتورك no one actually understand it. يعني الفيتشرز اللي عم تطلع ما هو هون عم تصير مصيبه بالاي اي ابلكيشنز، لانه الماشين ليرنينج عباره عن بلاك بوكس. هي بتطلع لي بفيتشرز وعندك مثلا algorithms بالماتلاب مثلا او بغيره you can actually visualize. راح تبلش انت تشوف صوره بتفوت لسياره بيطلع عندك فيتشرز ما it's hard for a person to understand or make sense of، بس هي الصوره شايفه انه those features represent. فاللي بصير جوا هاي الويتس that's actually the training process اللي هو الاوبتمايزيشن algorithms اللي بيحاول يلاقي لك convolutions unconventional تفهم منهم الفيتشرز تبعات الاوبجكت اللي انت عم تدور عليه. في اسئله هون ورا بس حدا يمرق لنا المايك لو سمحتوا.
يعطيك العافية.
الله يعافيك.
تمام. You talked about using classifiers in optical flow to classify certain data and videos.
Okay.
Can MATLAB use similar technology in classifying waves being imported into the software in real time? For example, classifying a certain waveform by its frequency or amplitude.
That's already been used. في عندك applications و algorithms that uses time series data. عم تفوت عندك يعني مثلا هاي بيستخدموها لما يكون في عندك certain equipment فيها sensors، مثلا heat sensors, vibration sensors، عم تاخذ real time data عم تفوتها على classification model. مثلا عم يعملوا frequency analysis وعم يعملوا statistical analysis، ببلشوا يطلعوا لك features من الداتا in real time وببلشوا يدخلوا الفيتشرز هاي على classifier. فمثلا هاي واحد من الاكزامبلز اللي كانت موجوده بشيء بسموه predictive maintenance. البريدكتيف مينتنس مثلا على الجت انجنز تبعت الطيارات ببلشوا ياخذوا قراءات من السنسورز وهي بتكون ريل تايم داتا. اوكي، ببلش يدخلوها على كلاسيفاير، ببلش يشوف الفاريشن مثلا بالفايبريشن اللي بصير جوا الجت انجن، ببلش مثلا بيعمل لك فريكونسي اناليسيس، ببلش يطلع لك فيتشرز، ببلش يقول لك I see that the jet engine is doing something strange, it's about to fail، فبيعطيك مثلا early warning. فهاي مثلا واحد من الابلكيشنز اللي بيستخدموا فيها اللي هو الكونتينيوس تايم سيريز اناليسيس. اهلا وسهلا. Any other questions؟ طولنا عليكم؟ لا we're on time. Thank you، يعطيكم العافية.